They're even in Antarctica. A lot of times these planation surfaces are on the tops of mountains. Like in Antarctica, some of the mountains that stick up are sheared off flat. Here's some planation surfaces in granite in the Beartooth Mountains of south central Montana, north central Wyoming. This is granite. It's been sheared off. And by the way, it's at different altitudes because of faulting. When you look at it, look how flat they are. It's as if Paul Bunyan got his big chainsaw up there and went to the Teton Mountains and zip, 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 cut off the top of the Teton Mountains and made them flat. It's the same rock as the Teton Mountains. Nature doesn't produce flat surfaces in granite. Strong evidence for the flood. And you have a lot of these other things, like the Wind River Mountains in Wyoming are flat-topped. Here's flat-top Square Top Mountain and a number of others in the area, 11,500 feet. Here's some sedimentary rocks on the west side of the Wind River Mountains, dipping down like here. This is a limestone, and it's been sheared off flat. Anyway, I'm going to sum it up by Lester King, who is a world traveler. And he's written a lot of publications before about planation surfaces and lots of other things in what's called geomorphology. Most scientists can't write, and this is poor writing, so I'm just going to point out a few things he says. He's pointing out a planation of extraordinary smoothness developed over enormous areas in all the continents. These planation surfaces are worldwide. In fact, Africa, 60% of Africa is considered a planation surface at 3 different altitudes. 60% of the whole continent. Australia has a lot of planation surfaces. Those 2 continents especially do you see a lot of planation surfaces. But they're on all continents. And as he said that these were formed over large areas, but since then they've been eroded down so that now you only have smaller remnants of a lot of these. But at one time, it was over a huge area. And he says the planation is extremely flat. Nature does not produce today flat surfaces. So here's the summary. This is what you'd expect if erosion that produced these surfaces was slow over millions of years. That's the uniformitarian idea. That's the alternative idea from the flood. This is what we should expect. Hard sedimentary rocks that are dipping, the hard rocks should stand up as ridges. The soft rocks are what was especially going to get eroded fastest, with some of the eroded debris ending up in the valley. That's what we should see. And we do see some of that. But the flood can still account for that, because if the floodwaters were going slower, it would produce more of a rolling surface. I believe these planation surfaces were formed by rapid floodwaters. But this is what we commonly find. Dipping sedimentary rocks, soft and hard, sheared off the same angle, and with a capping of rounded rocks showing it was water that did it. That's what we commonly find on the surface of the earth. Strong evidence for the flood, that the flood produced planation surfaces. This is a planation surface in the Little Rocky Mountains in north central Montana. Very flat, so flat they have an airport on it. Over to the left side you can't see. It's being destroyed. This is what we see going on today in nature. They're being destroyed. A river, or actually a stream, is actually cutting this up. It's destroying this planation surface. So the features I showed you, I believe, were when the water was moving off the continent as a sheet. But superimposed upon that, after this sheet flow, you had more channelized flow superimposed right on top of the sheet flow erosion. And that produced certain unique features that are difficult for them to explain. And when you move water that's moving as a sheet and it's forced to move more channelized, it's usually got to accelerate, like water in a wide pipe being forced to go through a narrow pipe. It's going to speed up, like right in here. It's maybe going about 30 miles an hour, and the pipe narrows, has to go about 50 miles an hour. So when you channelize the flow, in a lot of areas you're going to accelerate the flow. And it's going to produce all kinds of unique features. One of the unique features it's going to produce is what's called water gaps. A water gap is a gorge through a mountain or plateau or any other natural barrier where the river, if a slow process of erosion over millions of years, the rivers usually go through these water gaps now, but the river long ago should have gone around it, but didn't. It went through the mountain. There's a lot of rivers that go through mountains when they should have went around. One of the best ones is not very far from here at Cody, Wyoming, Shoshone Water Gap. How many have been to the Shoshone Water Gap at Cody? 1? 2? You ought to do a little more traveling. Anyway, it doesn't look like it. I'm in the Bighorn Basin. I'm looking towards Yellowstone Park up here in the distance that you really can't see. This is called the Rattlesnake Mountains. They're 2,500 feet above the Cody, which is right here. The Shoshone River starts in Yellowstone Park and moves east, and should have went around the Rattlesnake Mountains going that way, around here. I'll show you a picture there today. But instead, kept on going east and cut right, appears to have cut right through the mountains, gone uphill and down. 2,500 feet, forming a gorge. And when you get on the other side, this is Buffalo Bill Reservoir. It's about 300 feet high. This is where it should have went out. When the sediments were higher in the valley, it should have went out to the south, out this way. In fact, this is so low they had to build another dam out here to keep the water from spilling out into the Bighorn Basin. In fact, that's how they irrigate the Bighorn Basin, from an irrigation ditch right in here. The water should have went that way. Why did it cut through 2,500-foot mountain in a water gap? This is not unusual. There are a lot of these on the earth. The Appalachian Mountains are loaded with them. We have a lot of them in the west. The Green River cut through the Uinta Mountains. The Green River should have continued east around the Uinta Mountains or continued further east yet, but instead decides to take a turn to the south and cuts through quartzite and hard rock through almost a slot canyon, about a half a mile high, called